1 lesson 3. As I intimated in our last lesson, I was going to show you how we could perhaps do a query similar to what we did just before, but importantly to show what starts with. So in other words, I only type in A and that will show me all the houses that start with A. Type in L, it will show me all the houses that begin with L, but if I type in LO, it will show me all the houses that begin with LO. Again, we're going to do something similar to this query. So again, Control C, Control V. Oops, sorry. Control C, Control V. And I might call this starting with. You'll have to come up with your own idea of what's a good naming sorry, I'm trying to talk and type at the same time. A good naming policy and stick with it. Okay, so how do we change that? If I go into this one here, go into design, and all I'm going to do is change this part, and so I'm going to just zoom in on it, and this is how we get rid of that. We get rid of this. This is a wildcard that says to show everything that has this string in it. If we do that, that will actually mean show us everything that starts with what the person types in. Let's give that a go. Go to Datasheet view. Let's type in AN for Andrews. Shows us all the Andrews people. If we go into Datasheet view again, and let's type in L, that will show us Lodig and Lie. Lydig and Low, but of course if we type in LO, that will get rid of all the Lydig ones. So that's quite a good way, and quite often people like to be able to type in something that begins with. Okay, what we're going to do now is I'm going to do a couple of derived fields. In your assignment, you have to do something that is what we call a calculation field, and a calculation field is something that we can do a calculation on. An example would be where you have got someone's date of birth and you can calculate their age. Something where you can actually show the quantity of something is sold, the price that they sell them at each. Therefore, you can actually do a calculation that will calculate the subtotal, and then for that whole sale, where if they buy many products, many different types of products, it'll actually then show you the total price of that particular invoice. And what's really neat is what I'm going to show you right now is regarded as a calculation field, even though I personally don't think it should be. But that's what SACE says, so let's just show you. I'm going to do a calculation field, and when you do calculation fields for your assignment, you don't have to include multiple tables. I'm going to get a printout of all the students, sort it by house, and I want it to be in a nice format so that we can actually send a letter to those particular students. So what I want to do is put their first name and last name but together as their whole name, and I actually want to put their whole address together, and so I'm going to show you how we can do that, so that we can actually put that into later on into a letter that we can use. So all I'm going to do is look at the students table. So I'm going to make a query. it's going to be simply just the students for the moment. And we're going to make, straight away, we're going to make some derived fields. When you make a derived field in Access, you need to make use of colon. The colon says to Access, I actually want to make a brand new field on the fly. What you can't do is you can't name it a field name that already exists, and you can't name it a field that is as a reserved word. Examples, you wouldn't be able to name a field table because that's a reserved word. So let's just do that. So in field name, let's just call it, and don't use spaces if you can help it, student name, colon, and then, unless you know the syntax, I suggest you right hand click and build. And so it's here that we'll actually put some stuff in. So in here we're going to go into the tables, and we're going to go into students, and we're going to put the first name in. If it puts up this little XPR, we normally don't need to use that. Just click inside it once and delete. And what we're going to do is we're going to join their first name using the ampersand sign, which is a concatenation, with a quotation, space, quotation. That will put a space in, and then we're going to chuck their last name in there. Oh, before we do that, I needed to put an ampersand in there. Okay, so that's going to basically put their first name together with the space together with their last name, and it's going to be making a brand new field called student name. Okay, that's that, and we're now going to put student address. Going to build that. And we're going to use the tables. And we're going to put the address in. Again, if it puts that there, get rid of that straight away. And we're going to put an ampersand sign in, put a space in, quotation space quotation followed by another ampersand. So that's going to be the street address. Then we're going to put in suburb, join that together with another space, join that together with postcode, join that together with state. Now sometimes I miss out on ampersands and I get that wrong, so we'll just see. It will tell you if you got a little bit wrong. I've just noticed here that I've spelt student incorrectly there, and let's just see what the result of that is. Let's just make that a bit wider so it fits. And as you can see, that there is now ready for us, apart from some students that have got blank there at the moment, which are most of our students. We can now put that into Word, and it actually will say, if you do a few things like merging things, it will address a letter to Audrey Dendy, 69 Bologna Street, Madura 5443, South Australia. So that's that. Both of those are classified as calculation queries. So we'll just save that for a later date for merging to Word. And I might even call that QRY merge stud data. So we know that's ready for a merge into Word. Let's have a look. this here, just remind you about how we can calculate someone's age. I'll show what I want to do is perhaps if we do it this way, let's do another query to calculate the age, but then look at a calculation query that will then show us all the students that are under 14. Okay, let's just give that a go. I'm just brainstorming in my own head. Okay, so I want students and house. There you go. Let's go to create, query design, students, house. I'm going to stop it after this one because my hand's hurting. And what we want to do is see the name of students. You could do that derivation of their field again if you want to do. We're now going to calculate their age. We're going to put the house. We'll put the house in a little while. We're going to calculate their age. Now, their age is going to be based on this. So we're going to put age, colon, okay, and we're going to calculate their age, and we'll see how we go from there because there are a few little things. Well, to calculate their age, you right hand click, build. You get used to doing this once you've done it a few times. But how we're going to calculate their age? Well, we'll go into built-in functions, go to date time, and we've got to do this date now is older than their birth date, so we have to do that, take that. So we do date, take the date of birth. Now their date of birth is not in functions, it's in a table. So we go into the inbuilt tables here, and we go into students and we choose their date of birth. Here it is. And I always like to just make sure it's working. So I always say, you know, it's best to eat an elephant bit by bit. So I just want to see if that's actually working. So I'm going to go to datasheet view, and yes, it's working. How do I know it's working? Because that's how many days old they are. So now we've got to convert that into years. To do that, I'll keep on using the build option. What we do in here is we have to convert all of this into days. Now to convert it all into days, we have to actually do that, all of that answer, keeping in mind that computers always follow BODMAS, divide by 365. Let's have a look at that. Let's see if that works. If you're in a test situation and you really, you know, you can't remember this off by heart, I would suggest you use build, and just every time you do a change, you have a look at it and see if it looks right. Now, Connor Hornung is 18.56 years old currently. Let's go to design. Now, we need to what we call truncate that, mathematically truncate it. Now, to truncate it, there's a maths function. You can go in here, and in your maths function, there's a function called int, and int means to take just the integer value of it all. Now what we need to do is we need to do the integer value of all of this answer. So we do int, bracket, and finish all of it off in brackets, and go to OK, and let's go to datasheet view, and now that shows us all those ages of people, and that works quite well. So now we can actually do a criteria search on this, and we can do, I want to search all of the students that are less than 15. Okay, and let's have a look at that. So that shows me all the students that are less than 15. Let's do a search for all the students that are over 16. So we want to show you, and this is where you have to know what way your less than and greater than sign is. Let's do a search for all the students that are greater than 16. Let's put a multiple search in there. Let's put house in there, and let's do enter house, so the person has to type it in. Okay, let's have a look at that. Enter house, Jeffcott. So this is going to be showing me all the students that are over 16 in Jeffcott. Works nicely. Now, what do we do if we want to see those students that are between ages 12 and 15? Well, you can do a mathematical thing with greater thans and less than, but in actual fact, Access has got this neat thing that says between 15 and 17. This is going to show us all those students between 15 and 17. Okay, and let's put in low. And as you can see, it shows us all the students between 15 and 17 that are in low. Very powerful stuff. And you don't have to remember the mathematical equivalent of that, because between works. That's really nice. So let's save this one as QRY house students with a question mark after it, between 15 and 17. Okay, let's now make it a little bit more powerful. Let's say, for example, we wanted a staff member to have the rights of being, or the ability to type in, I want to see the ages between 12 and 18, 17 and 16, just the 14-year-olds. Let's see what we can do about that. Instead of the age group there, let's type in enter lowest age. I might just zoom in for you. Enter lowest age, and then enter highest age. Let's see if that indeed works. Because we're now starting to step up a bit, I'm going to now get the people to type in a part of their house name. So like that, followed by an ampersand and an asterisk. Now, because I haven't already done this, I'm just going to do file save as. Oh, hang on. File. Oh. Save object as. No, I've just lost. Anyway, this is going to be a better query, so I'm going to leave it as this. And we can, I thought we could just do file save. But it looks like I'm wrong. No. It's late at night, so I've forgotten. Let's not get hung up about that. Okay. This is a better one anyway. Let's go to datasheet view, enter lowest age, 12 and 14. Enter house, LO, and that should show us all the students between 12 and 14 in the lower house. Very nice. We probably need to just rename that though, because it's no longer, that's what we call static query, it's a dynamic query. So I'm just going to rename it. house studs age threshold. Now, this query, if you understand this, this is actually quite a few marks in an assignment and in a test. The reason being is that you've done a derived field, which is a calculation. You've entered in quite a complex criteria there, and you've entered another criteria that sorts things out. So that's quite a reasonably good complex search. I'm just going to introduce you to the idea of statistical queries, and then I've had enough. I'm going to have a rest, and if you finish it all, please by all means play around with the sort of queries I've done, add some more, get used to it, and we'll do another lot together later on. What I want to do here is I want to actually count how many students there are in every house. I don't want to show how many students there are. I want to actually count how many staff, how many students there are in each house. Now, a count is what we call a statistical query. Can you please write this down in your notes if you haven't? I need you to know that in a statistical query, in statistical queries you can do max, which shows you the maximum value, min, which shows the minimum value. You can do average, AVE, which shows you the average value. You can do a count, which shows you the count of how many records you've got in regards to a particular query. You can do total, which will add all the numbers up in a query. They are significant statistical queries that you need to use. Not all of them, but probably one or two in your assignment. So I'm just going to quickly show you how we're going to do a search. Now, can I please... Another thing for your notes is when you do a statistical query, you have to be minimalistic. You have to only put in the tables that are relevant. Do not put any other tables in that are not relevant to the search. So what we're going to do is we're going to count how many students there are in a particular house and how many staff there are in a particular house. So we're looking at just 3 tables. Okay, no more. So we're going to go create query design. I'm going to put in staff, house, students. We want to show the house of each one. We actually want to go in and we want to actually count. Please, we want to count how many staff IDs there are in each house. We want to count how many stud IDs there are in each house. And now, for us to do a statistical query, you need to come up here where that epsilon sign is, the thing that actually stands for a statistical query in Access. Click on that, and as you can see down here, it actually all of a sudden shows you an extra row. Here we can actually do these options. The ones that we will use most is sum, average, min, max, count, maybe first and last, not often but sometimes, and I will talk to you about where later on. So we're going to count the staff IDs and we're going to count the student IDs. That means we're going to count the amount of records of student IDs in each house. Okay, and we're going to sort in ascending order. Let's have a see if that works. If you can see there, it tells us that there are 130 staff in Andrews. Doesn't sound right. 130 students. Now I understand what I've done. I've tried to do too much in one go. So because I've done that, I'm now going to, you know how I said we should be minimalistic? Well, we're going to be minimalistic. We're actually only going to count the amount of staff there are in a house and then separately do students. And then we can join them together later on. So it's a little mistake that I made, but hopefully you'll forgive me. So we're just going to get rid of that. We're actually going to get rid of that table. We're actually going to get rid of this table, and we're only going to concentrate on staff. Okay, this time house. Group by house, yes, let's go there, sort, sending. That looks better. So we've got 4 people that are not in any house, 10 people in Andrews, etc. So let's save that, and QRY staff numbers, and let's do something for students. So create, query design, students, that's all we need. We want to count the students. Need to be a totals query. We need to put house in. And we want to sort by house ID. Oops. Sort in ascending order. And we want to count the student IDs. Okay. There we go. Now it might be a good idea for us to see the most students in a house down to the least. So let's do that. So I'm going to go to design. And I'm actually going to sort descending and turn this sort off. Okay, and I'm going to have a look at that. And so we can see that Leidig has got the most students. Now it's got house ID there, and maybe we're more, maybe we want to actually see the house name. Let's see what happens if I right hand click here, show table, chuck in the house, and in actual fact, rather than showing house ID, I get rid of that and put the house in. Let's see if it makes any difference, and if it doesn't, I think that's better. There we go. Okay, so when Mr. Richardson looks at this next, or Mr. Fraser, and sees that Leidig has got the most staff in it, next time we get a brand new staff member, maybe we'll give them to Hawker and Dola. So it's a useful query. That would be students, not staff, this one. Okay, and QRY student numbers. Please try all these sorts of queries with other databases you've got, or with this sort of database, because you do need to be able to do these in a test situation and for your major assignment. That's it for me. Goodbye.